Okay, here's the video on A3. So in A3, that was equivalent expressions. So we just looked at expressions like this, rational expressions, and we just tried to simplify them, or add and subtract them, or multiply and divide them. And then we also looked at radicals in this unit. Okay, so here's a rational expression. And when we're dealing with rational expressions, and we want to simplify them, the goal is factor them if possible. And then we see if there's anything that we can cancel out. So let's see what we can factor here. So the top is a simple trinomial. We're looking for two numbers that multiply to -12 and add to +1. So that would be x minus 3 and x plus 4. Then the bottom is a difference of squares. If you forget all your factoring, go watch the factoring video because you should know all the different types of factoring from grade 10. So x squared minus 16, difference of squares. So that's x minus 4, x plus 4. Two numbers that multiply to 16 and add to 0, or the square root of 16. Okay, so then we see that we have an x plus 4 on the top and bottom, so you can cancel those out. And we're left with x minus 3 over x minus 4. And we also want to state restrictions. So we never want the denominator to be 0. So all we have to do is set the denominator to 0 and then say, hey, we never want that to happen. So we're just going to take each bracket, x minus 4, set that to 0, and even the one that we canceled out, x plus 4, set that to 0. And those will be our restrictions. So now we know x cannot. And the other restriction, x cannot equal -4. That's the other restriction. Okay, so let's look at adding or multiplying, dividing. So here's two questions. So remember the dot means multiply. So we're going to multiply, but before we multiply, I'm going to factor and see if there's some stuff I can cancel out. So the top here is a difference of squares, so x minus 2, x plus 2. And the denominator, I don't see anything except for just a common factor. So I notice they're both divisible by 3. So I'll just factor out a 3, and then I've got x minus, 2x minus 3 in the brackets. So when I go to cancel, I'm just looking for things that are the same on the top and bottom. So the x minus 2's can cancel, and my 3's can cancel out. So then on the top, I'm left with x times x plus 2, and my denominator is just 2x minus 3. And there's nothing else I can cancel. And if I want to say my restrictions, x cannot equal 2 from this guy here, and then from this bracket, x cannot equal 3 over 2. Okay, the division one, x minus 3 over x minus 4. I'm going to change my division to a multiply, and then I'm going to flip the second fraction. Let's do that at the start. And then I'm going to see if I can factor anything. So the top is a simple trinomial, so I'm looking for two numbers that multiply to -8 and add to -2. So that works. The bottom is a difference of squares, so x minus 3, x plus 3. Then I'm just looking for stuff I can cancel. So I've got x minus 3's and x minus 4's that will cancel. So all I'm left with is x plus 2 over x plus 3. And then if I want to state my restrictions, just look at all my denominators. I know x can't equal 4, x can't equal 3, x can't equal -3. So I just set each term equal to 0 in my denominator. Okay, when I'm adding rational functions, I need a common denominator. So a common denominator between x minus 3 and x minus 2 is just going to be multiplying them by each other. So I'm going to take my first fraction and I'm going to multiply it by x minus 2. I'll multiply the top and the bottom by x minus 2. And my second one I'm going to multiply by x minus 3 on the top and the bottom. So then what I have is 2x, x minus 2, plus x times x minus 3, and the whole thing is over x minus 2, x minus 3. So often when we're adding and subtracting, we need a common denominator, and if we can't figure one out, we just use both of them and multiply them by each other. So that's what I've got, and then I might just want to simplify the top, because I know the top is actually, this is actually 2x squared minus 4, and this is actually x squared minus 3x minus 4x. So if I collect like terms, I get 2x plus x squared. 2x squared plus x squared is 3x squared. I've got negative 4x plus negative 3x, so that's negative 7x over x minus 2, x minus 3. And if I want to state some restrictions, and x can't equal 3. Then we learned about radicals. So 3 important things you need to know about radicals. You have to be able to change them into kind of like their lowest form. So we're just trying to think of perfect square numbers. So numbers like 1, well, who cares about 1, but 4, 9, 16, 25, 36. So all of those are perfect squares. So when we take the square root, they equal a whole number. So the square root of 20 is made up of the square root of 4 times the square root of 5. And we know the square root of 4 is 2. So the simplified version of root 20 is actually 2 root 5, which means 2 times root 5. Okay, also we need to know how to add and multiply radicals. So to add them, they have to have the same radicand. So like 1 root 3 plus 2 root 3 is actually equal to 3 root 3. If you had, for example, root 2 plus 3 root 5, well, you can't add those together at all. So you have nothing to do. It would just equal what it is. Okay, and then when you multiply, you can multiply anything you want. So we just multiply the radicands by each other and the numbers out front by each other. So root 6 times 2 root 3 becomes 2 root 18. So we multiply the 6 and the 3 together. Plus root 24. And then we just see if we can simplify. So root 18 can be broken down into root 9 times root 2. Root 24 can be broken down into root 4 times root 6. And the square root of 9 is 3 times root 2. Square root of 4 is 2. So we're just simplifying. Then we can multiply these two things. So 2 times 3 is 6. So I've got 6 root 2 plus 2 root 6. And I can't add those together because their radicands are different. So that would be my final answer. So that's everything we learned in A3.